Our next presenter is going to be Dr. Kevin King. He's been a very busy guy the last year or so with these edge of field studies.
Thanks for the opportunity to share today. I guess I will apologize up front for those of you that were in the room yesterday at CTC. You're going to see the same presentation. I did update a couple of things last night. They just didn't make it into the slides, so I'll talk about that as well. So we're going to talk a little bit today about the edge of field, where we are right now, an update on the data that we've collected thus far, and some of the trends that we see. So first off, I'm going to go through a balance. We've tried to do a phosphorus balance at this, and we're going to talk solely about dissolved phosphorus here with respect to the data from those sites. And then we're going to look at things through a 4R lens. And then finally, we're going to talk a little bit about some of the treatments that we're investigating at this point. So if you've driven the landscape, you've seen this type of structures out and about, no doubt. This is a typical edge of field site where we have both the surface and the tile drainage captured from an edge of field. Now, when we go in and we start to work with the producers, our design has been a paired design, meaning that each site will have two of these. We've got two surface components and two tile components. And the idea being that we'll collect data for a period of time, what we call the baseline condition, and then we will make some type of change on one of those fields so we can actually quantify the impact or benefit of a specific practice. So to date, sites have come and gone due to land sales, retirements from farmers, whatnot, health issues with some of the producers. But today, you can see the black dots is where we currently have sites. We've got 20 paired sites right now, so 40 fields where we're currently operating. The two newest are here in Hardin and Hancock County. They're part of the NRCS and Ohio Farm Bureau demonstration farms. They came online in October of 2016. We started this effort back in 2010, 2011 is the life of most of the sites right now. We had some sites that some of the ones we lost actually went back to 2005. But so this is where we're operating. Several of those you can see are in the Western Lake Erie Basin, the Sandusky Basin as well. So let's just look at the data as a whole. So when we collected our data, this is event mean concentrations from, and again I should have updated this. This side over here is the dissolved phosphorus. This side is the total phosphorus. Both coming from the surface and coming from the tile. The red dashed line is the Annex 4 recommendation concentration of 0.05 for the dissolved. And so what we see is our event mean concentration. This is about 4,200 rainfall events collectively over the life of the study from all the different sites. We can see that the median concentration coming from the tile is actually at the threshold that we're targeting. And that what's coming out of the surface is about 3 times greater. The median is about 3 times greater than that. So the water is going to go somewhere. Argument is if the water is going to leave the site, we'd rather have it trying to go through the soil, some of those nutrients being pulled out, using that soil sort of as that natural filter and reducing the concentration that can come out. That doesn't mean tile is a free pass. And I'm not sitting here advocating that tile is the solution. That's not what I'm saying. But I am saying that in this landscape, we have to have tile drainage to farm. And so, yes, tile drainage can reduce the concentration, but we also have concentrations. This is the 95th percentile. We actually see concentrations coming out of the tile that are about 1.25 parts per million in some sites. So we do have some issues. And likewise on the surface. I mean, we've got concentrations that are, event mean concentrations that are upwards of 2 parts per million. So we do have some issues to address. So that's the concentration story. And this is a busy graph, and we won't go through everything, although what I do want you to note here is the black areas in these is what we're getting from the subsurface. This is the loading. So now that we're taking this and merging those concentrations with the water component. And when we do that, we see that most of the loading is actually coming from the tile. And so we have to be aware of what our tile drainage is. And you can see sort of sites as they came online to where we're up now to the full 40 sites that we're currently monitoring. The red dashed line here is that Annex 4. So if we think about Annex 4 and we talk about the 40% reduction, and I take that and so what's allowable is 60%, and I divide that evenly among all the acres in the basin, we come up with roughly a quarter of a pound an acre, 0.3 of a kilogram per hectare. And that's what the red dashed line it represents here. What's encouraging when I look at this is generally we've got about 30% of the farm fields right now that are meeting that threshold. We have another 60% roughly that are on the verge of meeting that threshold. So we think we have tools in our toolbox, and if we have the resources for NRCS, for the soil and water districts, the TSPs, the CCAs to work with these producers, we think we can get that other 60% in alignment relatively quickly. And then we do have 10% of the sites that are going to take a lot more effort. Our 4R practices are not going to get those back in alignment. But we're going to have to do some other edge of field means to address some of those specific sites. Weather does play a role. Again, this is looking at all the events that we've collected so far, roughly, I said 4,200. If we look at that, and this is just an exceedance probability plot, so if we look at the 20th percentile here, that's roughly about 30 millimeters of rainfall. So roughly 1.25 inches, between 1.25 inches, 1.5 inches of rainfall is where we're getting 40% of all the flow and the nutrients that are leaving the tile are coming with those large events. It's about 60% of the loading and about 70% of the discharge is coming through the surface with those large events. So the question is posed is how do we store more water in the landscape? I think that's, when we start talking about nutrient management, it's one thing to ask producers if they have a nutrient management plan. It's another when we ask them if they have a water management plan. Because water is just as critical as the nutrient is. If we can control the water, we can control most of the problem. If we think back to 2012 and we think back to 2016, we did not have large blooms in the lake. And we feel that the result, we didn't have water going down. Those were our drought years. That's when we didn't have water going down the river. So now we'll turn our attention. Let's just ask this simple question. Are farmers in Ohio doing a good job of managing phosphorus? And not a slight, Shannon. I think you in Indiana are taking care of things, right? Yeah, so we'll ask this Ohio just because that's where our data exists right now. But so when we think about our phosphorus budget, so we just talk about our inputs minus our outputs being that budget. We can talk about atmospheric deposition. It's the amount of phosphorus that's coming through rainfall that we cannot control. Then we have the fertilizer and manure that can be controlled by the producers. We have crop removal, that amount that's taken off in the grain and the biomass. We lose some to surface runoff, and we lose some to our leaching or tile drainage. So if we think about each of these components, let's look at those a little bit more. And this is all of the fields right now that we currently have. This is the 40 fields that we have in our system and our network right now. Everything is accounted for here. So it's regardless of the rotation, the P source, the placement, the timing, any of that. This is just all the data collectively. So let's look at atmospheric deposition. It's roughly 1/10 of a pound an acre. And that's from the historic literature. I think some even here, Dave Baker, I think you even had some of this data that pointed to that number as well. So on an annual basis, we get about 1/10 of a pound an acre coming from the atmosphere in deposition. And then we look at what's applied from a producer standpoint. And on average, that's about 19 pounds an acre. But notice the range from 0 to 100. The 0 would obviously be when we're, and which is the typical of most producers here in the state, we'll put on a 2-year application. We'll put on nutrients, our phosphorus before corn planting or right after soybean harvest, and then we won't put anything on with the soybean. So that captures the 0. And then we've got a pretty high application here of 100 with a median of 14. So our total phosphorus inputs coming in from these fields is roughly 19 pounds an acre is where we currently are. So now let's talk about the outputs from those same fields. And we've got 2 producers that just in our neglect and when we collected the data, we've got the question into them right now, but we had 2 producers that didn't provide their yield data to us on one occasion in each one. They had corn and soybean in the rotation. So for that system, we assumed 160 bushels per acre of corn and 45 bushels per acre of soybean harvest. So if we look at that, we see that on an average annual basis, we're removing about 23 pounds per acre in the harvest. That range is 0 to 37.5 with a mean of 22. The 0 might say, well, why aren't we removing anything? That represents one of those stale seedbed applications. So we'll harvest wheat, and then we'll wait and plant corn into that, and that corn won't be harvested because this is water year data. That corn won't be harvested until October or November of the following year. So we don't have a yield in that period. So thus we don't have a removal in that situation. And then we look at where we come from with our surface runoff and our tile drainage. And again, through the surface runoff, as I said, we're getting about 0.2 of a pound per acre is coming from our runoff. But you can see we've got our range is pretty high. We've got 2.5 pounds an acre coming off of some of that surface runoff at some of the sites. And then our tile drainage, about 0.3 of a pound per acre. So in our surface runoff and our tile drainage, we're getting roughly 0.5 pound per acre. So from a farmer's standpoint, 0.5 pound per acre is pretty good. When we're considering we're applying 19, 20 pounds an acre, and now we're gonna lose 0.5 pound. We're talking 2%, 2.5%, 3% of what they're applying. From an agronomic standpoint, it's pretty phenomenal. But it's exactly that amount that's causing the problems in the lake. So what we have to do now is try to find that balance, that agronomic balance and the environmental balance to where we can reduce that even further. So our total P outputs are about 23.5 pounds per acre. So if we look at all this, and this is 106 site years of data, if we look at this, we've got our 1/10 of a pound of phosphorus from the atmosphere. We've got roughly 19 pounds an acre from the fertilizer applications. We're removing 23 by the crop. We're removing 0.2 with the surface, and we're removing 0.3 with the leaching or the tile drainage. That's a balance of -5. So if we look collectively at our sites right now, we're drawing down about 5 pounds a year from these sites. And that range is -23 to 29. Now, Bill, you asked a question yesterday in the meeting, so I went home last night, and it got me to thinking. Bill asked me yesterday, well, what's the story about the sites that are using manure, and is there an imbalance, so to speak? We talked about some different things, and are we being unfair to those producers that are using manure and the 100 barns that are going to go in from Findlay to Fort Wayne here that are already on the books? Are we being unfair and not letting them know what the real risk is, and are they going to have enough acres to spread? And I don't have my glasses on, but I will tell you, so we had one producer that was not putting any fertilizer on. It was the producer where we had a lot of fertilizer being applied over the years. He's not put anything on in 13 years. So I thought we ought to take him out of the system, out of this number. So that lowers this number or increases this number to about 2.7 pounds an acre when we do that. But the interesting part was, what are we doing with the commercial guys using commercial fertilizer versus those using manure? And that's where we did see a difference. Where we saw the guys using the commercial fertilizer, that number went to -11. But when we went to manure, where we had the manure in the system on a regular basis, it was positive 4.6. So we do have an imbalance. And the guys that have manure in their system are generally losing a little bit more than the guys that are typically drawing down that are not have manure in those systems. So I think it's something we want to talk about, and I've got some slides here that lead to that a little bit when we start thinking about manure and rate specific. So I posed the question, are farmers doing a good job? There are small P losses in the surface runoff and tile drainage relative to that amount applied. We talked about that. How do we balance the agronomic and the environmental part of things? Average crop removal rates are greater than the average amounts applied, of P applied generally. We just talked about the manure. When we have manure in the system, that may not be the case. And our P balances are near zero. However, good may not be good enough. This was an article done in 2016. This is data from the Maumee. This is the accumulated phosphorus since the middle, about 1975. This is where we are today. We're near that zero budget. And that's the legacy P. We have built phosphorus up into our system to where we have a lot of legacy phosphorus sitting there. So, water quality problems are quite likely to persist for some time due to that legacy phosphorus. I think that's our culprit. That's where we have to really start to address to some extent. We're doing a pretty decent job. We can start to draw down. We can further draw down here, but we've got to understand, due to this, it's going to take a long time to address this issue. So, if we think about a phosphorus budget, our aspirational budget is going to be increased yields, it's going to be decreased losses and decreased inputs. That's what we all want. How do we get there? Well, I think one of the methods to get there is this idea of the 4 R's of nutrient stewardship, the 4R program. So I want to look at the data now, all of the data that we've collected thus far with this 4R lens, so to speak. So let's look at sources of fertilizer. And when we look at the top graph, that's P loading from all of the different sites that we have, from all 40 fields, whether we're using an inorganic base of fertilizer, a mixed base, or an organic alone. And that's, you see the dissolved reactive on the left and the total on the right. Now, when we first look at this, you're going to say, well, organic is the problem. That's not what this says. What this is reflecting is a historic mismanagement of phosphorus or our nutrients. So when we took data, or we went into these sites, a lot of these sites had soil test levels of 100, 200, 400 parts per million. What we're measuring is that legacy effect. We're measuring the history of that's been applied. So our question was, what would happen if we applied phosphorus using an organic source and an inorganic source at the same rate? And so one of our producers indulged us that and actually did that for us, and that's what's on this bottom graph. So this was put on at an equal rate in 2015. So this is 10, 11, 12 months worth of data now that we have. And what we see is there's no significant difference between using a liquid dairy manure or using MAP at the same rate in the event mean concentrations over time. Nor is we see any difference in the total phosphorus as well. So I think what it's saying is, as long as we manage the nutrients and recognize the phosphorus in the manure, and we were to apply it at the same rate using the same 4R principles, we should expect not to see any difference whatsoever. The risk are there. So we have to understand that we need to apply and account for the nutrients in the manure and make sure that we're applying them at the same rate and recommendations that we would if it were a commercial fertilizer. So now let's look at rate. And this is just a collective view of what the producers are applying right now. I haven't tried to put loss data with this. But this is the P205 application in kilograms per hectare. The line here is the tri-state recommendation. So if you go in, that's either for corn or wheat. They're roughly the same. There's a little difference on the bottom end of that, but basically it's the same. But what you see is a lot of our producers are below that envelope, but we have some that are well outside of that envelope. So we have work to do. A lot of this application, these small amounts right here, is starter fertilizer. In these cold, wet soils, we almost are forced to use a little fertilizer out there. But the bulk applications, I'm not convinced at this point that we need as much. And I think that goes back to that legacy figure that I showed you before. We have a lot of phosphorus in our soils right now. But so we can see that by and large they're doing a pretty good job, but we do have some, looking at a couple of these organic ones. Why are we still putting on a site that's 120? It's a great question. Can he do it? Sure. Should he be? Absolutely not. And I think that's an education thing. I think that's where we need to make sure we're going in and working with those producers, making sure in our CS, soil and water districts, the CCAs know about this so that they can help hopefully address. And hopefully the producers will open up their door and let them be there. Don't worry about the graphs here. This gets into the timing of fertilizer. And generally, if you look for the hot areas, the reds, the greens in that, then basically you see the larger the rainfall and the closer to the time of application, the hotter the color, which makes sense. And that's what we see in the top four graphs here with respect to dissolved phosphorus. And the white dots are the points that we actually have. Those are our data points. What was interesting as we started looking at the data was maybe these bottom two graphs, and that's the time of the year. So when we start talking about fertilizer timing, there's two aspects to that. There's time since precipitation, and there's time of the year. And what's interesting is we do see a fair amount of the nutrients going on at planting here in April and May. But we also, what we noticed here is we do have a few guys that are applying over here in June, some in this window here, not as much as we'd like to see. But if we look at this, that's the period, if we can get small grains back in the rotation, that we think provides us a window of opportunity to apply our nutrients when we would expect the least amount of large erosive rainfalls and the least amount of losses. I know there's a big push going on in Northwest Ohio right now to get barley back in the system. There's a malting facility being proposed, and it would be nice if we could get that installed there. We could get 100, 200,000 acres of barley back in the system. Barley would allow us then, it's harvested generally 2 to 3 weeks earlier than wheat, so it would allow the producers not only to have an over-the-winter cover crop, but would it also allow us to then hopefully get a bean crop in following that. So that's with respect to time of application. And then let's talk a little bit about losses and fertilizer placement. So this is an application in May of 2014. You can see the prills of fertilizer here, and these cracks are actually pretty small compared to what we can see in Northwest Ohio, especially in some of the Paulding clays and the Hoytville. You might lose a limb in some of those sometimes. So, but we went in with this producer, and this was the application. This was on April 28th before that May application. We can see that the side-by-side comparison of those fields, they're responding the same, which is what we would expect. That's the whole reason behind that design, that paired design, is that we look at the average concentrations, they're the same. The loadings are essentially the same from that field. I was standing in the field with him when that application was made, and he said, well, I want to till this in. I don't like the looks of this on the surface. And I said, well, Jim, remember, we're still in the baseline period, so if you would, I would appreciate if you would till both fields. He tilled one. So that's the way farmers are. They have a mind of their own sometimes. But it gave us an experiment. And so he did a 3-inch disc tillage on one field. And in the field that he tilled, we saw the concentrations coming out of the tile was reduced by 5 times. And the loading coming out of that field was reduced by 7 times. I'm not standing up here advocating for tillage. That's not what that this is about. But what we do know is if we can get the nutrients placed below the surface, subsurface placement, we can see a significant reduction in the losses. As I was talking just to Dave earlier, there's a lot of sediment in the lake right now. We've seen a lot of erosion. The last thing we want to do is be recommending tillage and going back to that situation. The harbor already it cost them what, $5 million a year, whatever, for dredging. We don't want widespread tillage to continue and to cause that problem to be worse. But there are a lot of toolbars out there right now that do allow subsurface placement, 3, 4, 5 inches below the surface in a no-till environment. So you have cover crops, you have no-till, those toolbars exist. And that's what our recommendations are right now. We're not asking the producers to go out and buy new toolbars. I mean, these things are $80,000, $100,000 toolbars. What we are asking them is to consider the next time they are in the market for one, to please consider that, because that is what we need to make this happen. We've got to get those nutrients below the surface. Finally, I'll talk just a second about cover crops. We had a producer that was in 2015. He went in after corn harvest and he put cereal rye down on one field and not the other. It was the first treatment, starting one of the treatment sites that we had. What we saw in that situation was significant reductions in the nitrate losses, to the tune of one of the fields. The field without the cover crops was losing 33 pounds an acre. The field with the cover crops lost 1 pound per acre of nitrate. So significant holding back of nutrients. The catch crops really did their job there. We also saw a significant reduction in the amount of tile drainage that came from that site. The site with the cover crops had 2.5 inches less drainage water leaving the site as compared to the site without cover crops. So if you think back to my 4th or 5th slide, when I said weather plays a role and we talked about those 1.5, 1.25, 1.5 inch rainfalls, how do we keep more water in the landscape? Cover crops and organic matter is one of those. It was the more organic matter we have, for every % organic matter that we have, we can store roughly about 3/4 of an inch of water in our profile. Most of the soils up here in northwest Ohio, when they were formed, were in that 5.5% and 6% range. Right now, they're down around 1.5% to 3%. So if we can get those soil organic matters back up, then that's going to go a long way in helping us to store more water in the landscape. Now, I said we're going to primarily talk about phosphorus. I gave you some nitrogen numbers there. Now let me talk about the phosphorus. There was no significant difference in the phosphorus losses with the cover crops. They tended a little low to be lower in the field with the cover crop, but it was not statistically significant. We did not see those drastic changes. Now this is, again, 1 year of data. Yeah, Shannon.
Would that be concentration or load since you had less runoff?
It was both, actually. So we saw no difference in the concentrations, and the loading difference was due to that less, but we didn't see any difference in that. So again, it's early. It's 1 year of data. I think we definitely need more data on this topic to see if we do see a difference. But besides that, there are other advantages to this idea of no-till and cover crops that I think we need to be taking advantage of, and that is our soil health issues. It's a nitrogen issue. While nitrogen may not be the focus here, nitrogen does control the toxicity of the blooms. Phosphorus controls the size, nitrogen controls the toxicity. So I think we have to be aware of that, and we need to be addressing that issue as well. So Greg Labarge and I were out back in the fall. We've got several of the producers that are targeted now are scheduled in the fall or spring this year before planting to start implementing some type of practice. So we've got our baseline data. So in that, these are the treatments that we've sort of laid out right now. We've got a producer, actually we have two producers that have looked at gypsum as a surface amendment. We do have data on one of those already. The other one's just started that practice. We're looking at both fall and spring application timings, and that's both with organic and inorganic sources. We're looking at a rate issue, whether we're using a full rate of phosphorus or a half rate. Drainage water management, how do we control that water in the field? That's one of the things we're looking at. Multiple versus single applications, and that happens to be a manured site. The producer is actually moving away from, he had continuous corn in his field for silage, and he was applying either before planting or after the silage was taken off. He's actually going to put sorghum sudan in, and so he's going to get 3 cuttings out of that, so it opens up more opportunity for us to make multiple applications. So we'll be able to hopefully investigate that practice. Producer where we've got our hottest site is going to go into a drawdown mode on one of the fields. He's putting alfalfa in, so to see if we can actually pull that down and actually remove that biomass. Conventional versus no-till and reduced till. So the producer that I talked about with the cover crops, his whole idea was I want to go full cold turkey into no-till and cover crops he tilled every year. And so he did that this first year, and he felt like it was a disaster. So we're working with him. Now I talked to him yesterday at the CTC conference, and he said, I want to still do it, but I want some, are you okay if I have to do something? So it's one of these education things with some of these guys. So he's going to definitely, what I will call, go to reduced till, and hopefully we're going to get him to the no-till and the cover crops eventually. Organic, looking at continuing that organic versus inorganic study. We're going to be looking at this. We've got a producer, a long-term no-tiller that uses strip till, and so he's agreed to continue that strip till or banning of the fertilizer on one field, and he's going to do a broadcast application for the other, so we'll get a direct comparison of those two. Again, continuation, trying to look at the cover crops versus no cover crops and that impact. And then lastly, this idea of wood chip bioreactors and steel slag filters. We've been collaborating with Chad Penn, who was at Oklahoma State and is now with ARS over in West Lafayette. And ERC is here. They helped us in the beginning put a couple of these steel slag filters in. And so we're just now starting to get a little bit of data on those. It looks promising, but that's really all I can say at this point. And then again, with the wood chip bioreactors, the same thing. So that's where we're headed. Again, over the next couple of years, we'll be collecting this data. It's really going to take a year or 2 years of data before we can really start to say, yes, it does work, or no, it doesn't. We feel like that directionally these practices are correct, but we don't know whether they're going to save us a quarter of a pound or a half a pound or 2 pounds an acre. That's what we don't know yet. So in conclusions, I like to say that there's no smoking guns out there. We don't know what caused the problem, and likewise, there's not a silver bullet to take care of it. It's going to take a lot of these different practices in order to address this issue. The producers right now, by and large, are generally doing well with the P management, but they can improve. We can all improve. These are not zero discharge systems, and until we get to that, then I would say there's improvement that can be made. Due to the legacy P, water quality problems in the lake are probably going to persist for some time. There's no way to get around that. This didn't happen overnight, and it's sure not going to solve itself overnight. We talked about the water management. Accelerated water management as well as phosphorus or nutrient management is going to be essential to address this issue. At a minimum, every producer should be following the 4 R's of nutrient stewardship. That's the eating right and exercising that we should be doing. As a producer, everyone should be doing that. And I think we need to recognize the importance of field budgets, of phosphorus budgets. If we can create those phosphorus budgets at the field scale, then we can start to identify practices that will address that. And I don't know if Greg is still here or not, but I know Greg Labarge, I hope he highlighted the Ag Management Handbook that he is creating and the website that they're creating to actually point to some of those practices that are critical in addressing this issue. So with that, I need to acknowledge the funding sources. Through time, there's different sources. I hope I haven't left anybody off. I'm sure I have, and I apologize if you're one of them. But through different grants, through different folks, now parts of this were put in at different times. More recently, the last 3 or 4 years, NRCS has really been the heavy lifter in helping us to continue this on and keep this going. But there's been a lot of people that have been involved throughout the years that have helped us to get this established. So, and then I finally have to acknowledge my group. I'm just a spokesman anymore. Unfortunately, I don't get to go out and have fun and do things. But this is, I've got a great group of staff that actually do most of the work. They go out in the field and do the data collecting that. We touch 19 counties every week, about 1,300 miles and about 300 or 400 samples every week is what we're out collecting. They don't really drive this fast, but it was a good photo anyway. So, but I do have we do work fast, but we do have a phenomenal group. So with that, I will stop and answer questions if I have time. Bill?
Well, in your presentation where the man is going to grow alfalfa and need a drawdown,
Yeah.
is gypsum going to be considered in that site? Because that would definitely help with that alfalfa crop and using more.
So he's done 3 years worth of gypsum application right now at a ton per application. That's the gypsum data that we do have. And we have seen some effect, and I'm hoping he's going to continue on. But so that is the plan right now.
The second one is, do you see a direct correlation in soil P test levels of elevated levels and elevated loss?
Yes, we do. There is a relationship there. Yesterday, my postdoc that's working with Emily Duncan is actually investigating that. There are a couple of break points in there, but yes, in general, there is it's not linear. There's a nonlinear relationship there once you get above a certain point where you do see elevated losses.
So there's hope that we can come up with a level that would be acceptable for crop production and environmental impact.
That's the hope. That's exactly what we've been trying to tease out right now. It's not been as clear as we first thought it would, but yes, that's our intent. So, yes, sir.
On your slide you had there on cover crops and the non-reduction of DRP. So I heard you answer the question, but if there was no reduction, but yet there was less coming out of the tile, there either had to be more concentration in that water or it was reduced.
Yeah. Statistically, there was no difference. Yes, there were some minor differences, but they weren't statistical in nature. So, but yes, you're absolutely right. It's got to be one or the other. If you got less water, it's either got to be increased or concentration. But they weren't statistically significant. We saw no statistical difference between the two sites. Shannon?
What year was that data taken?
For which one?
That one that you were just talking?
The cover crop, the cover crop would have been seeded in November of 15 or October of 15.
So is this last year?
This last year.
When we had a dry year?
Yes. Yeah.
There really wasn't much water movement.
There was a fair amount, yeah. I mean, there wasn't a whole lot, but we did see water movement, yes. Shannon, you had a...
On your site where you had the long-term no-till and the guy tilled to one side, that was 14 data. What did you see in 15 and 16 on the sites?
I haven't looked at it in depth to follow. Yeah, we haven't. I haven't looked at that, Shannon. So good question, Jeff.
Yeah, Kevin, great job as always. But I see this, and I'm always thinking when rather than paint a broad brush of, 1.5 pounds per acre or something like that, you're talking about the legacy phosphorus. Not every field is a legacy field.
Correct.
And the 0 to 29 pounds or 200 pounds per acre, big ranges coming off. It just seems to scream at us that we've got to some way figure out how to identify those legacy fields, because then those fields also become the most likely places to put your wood chip and your steel slag. Those are the places we should be focused on.
Well, I'm going to respectfully disagree. That I think we do have that built up. I think those farms that do have just 25 or 30 parts per million still have a lot of phosphorus out there. I know that, well, Steve Coleman has it now, and it was Robert Mullen's data before. I keep begging them to publish it, but I know they've got data from Hoytville that actually soil that's an agronomic level. It's about 30 parts per million. They didn't put phosphorus on for 10 years, and they're not seeing any difference in yield whatsoever. Now, they've not done the water quality, but we've done the water quality data with Laura here, with the Maumee tributary and Cedar Point, and one of our, or Cedar, not Cedar Creek, the Portage, and one of our edge of field sites that was at the agronomic level. We see the exact same, the losses, the concentrations coming from that field are exactly what we're seeing there, but they're still above that 0.05 level. I mean, they're still to the tune of about 1/10 of a part per million. So I think there's a lot of phosphorus in the soil, regardless of whether that soil test level is there or not. It's in different pools, and I think that's the unknown. I mean, we just got a paper accepted, published, that calling for different soil tests, because I think there's a lot of microbial things that we don't understand, that there's a lot of phosphorus that's being moved across different pools and becoming available at times. And so I think there's still a lot of phosphorus out there that we need to do a better job of accounting for, that we're not. So, Steve?
Yeah, along that line, you made a comment yesterday, which I was listening for, but I didn't hear today.
Dang it.
But I'll cue you. But someone asked you about getting the elevated spots or the hot spots, or how far that would go, and your comment was it wouldn't get us there.
Yeah. Good point, Steve. So the question yesterday that I got was, we talk about those 10% of the sites that are hot. Well, one, it's very hard to know where those are, just through the privacy laws and that. But if it's just a simple math balance, if we were to address those sites, it would not get us to the 40%. We've got to. So it's not as simple as just saying let's find and identify those hot spots. I think it's going to take addressing all the producers, and that's where I think all the producers can do a better job. We've got some doing phenomenal. Can they do better? That's where we have to figure out, is it economically they still have to make a living, and can they really do that from a budget standpoint? But to answer your question, Steve, yeah, addressing those hot spots alone, I don't believe is going to get us there. It's not going to hit the 40%. We're still going to it's still going to rely on addressing the other 90% of the producers too, and they're going to still have to reduce further. So.
One more. Josh had a question on your.
Yeah. Okay. Yeah.
Do you have an idea of what the DRP to TP ratio is, kind of across the board?
I haven't looked at it across the board, but it's probably going to be in that 50 to 60% range, maybe 70% range on the tile. It'd be a little higher on the tile. We'll get more DP than TP, but overall, it's probably in that 50. DRP represents about 50 to 60% of the TP. So, Bill, he's going to let me ask you. Yeah.
Just to counteract Steve, which no disrespect.
Wouldn't be the first time.
I guess the situation that everybody, when they hear that, without having a quantifying number, because we get this question all the time. Does that 10%, so it doesn't get us 40, but does that get us 20? Does that get us 25? Does that get us 15? Without you, the researcher, being able to put that number and say, what really bang for the buck moving the needle does it get us?
Yeah, that's a great.
Here's what they want to hear in that.
That's a great point, Bill. I mean, and I need to do that. I need to try to quantify that number. I don't know when I'm talking next week.
Give you the direction that we need to go.
Yep, I agree. Good point. Good. All right.
Yeah, I think with Kevin King's information, we could go on and on for a while, but I think Kevin's got to dive out and go somewhere else at a meeting.